Hi, welcome to the lecture series on process control automation. This is Nagarjuna, and today's topic is PLC, Programmable Logic Controller. Let's look into the topic. Basically, the definition of PLC. What is a PLC? A PLC is a user-friendly, a microprocessor-based specialized computer. Right, it's a digital computer, nothing but. So here in the PLC, it makes use of a microprocessor, a very powerful microprocessor, which is responsible for the execution of a complex instructions or execution of the logic. So here it performs many types of levels of complexity. The main purpose of its is to monitor the crucial process parameters and adjust the process operation accordingly. It can be programmed, controlled, and operated by a person who is PLC literate. Now, let's come to the overview. Basically, the PLC consists of three major components: the input module, CPU, and the output module. Now, what is the significance of the input module? The input module will acquire the information from the field devices. When I say field devices, it can be a sensor or a transducer, a switch, or a proximity, or it can be anything, right? So all the field devices are connected to the input module. So the input module is responsible in acquiring the information from these field devices, right? And this information is conveyed to the CPU by optical isolation. Here, there is no wide communication between the input module and the CPU. The communication is without a wide communication, through optical isolation, the data is going to be transmitted. You may ask, why this isolation? The isolation will protect the CPU from the field devices, because the field devices are in the, it may be exposed to a high voltage or a noise, or it can be anything. So it should not affect the CPU or the operation. So that's why we use this isolation protection from both the sides, from the input module as well as from the output module. Now we can see this, the output module is also isolated, right? So the input, the information acquired from the input module is sent to the CPU, and the CPU is responsible for the execution of your program. So CPU will execute the logic, and once the execution is done, then it comes up with the solution. So that's a decision, nothing but. So that decision is transferred to the output module, and the output module is responsible for the execution. So it will ensure that the output will be either it can be turned on or it can be turned off, right? So this decision is based upon, purely it is based upon the logic and based upon the input status of the field, right? So like this, the operation will go on, and this operation will go on continuously, because in the PLC there is a program cycle will go on. In the program cycle, continuously it will perform the input scan. With the help of the input scan, it will get updated with the input status. So whatever the changes occurred across the input will get updated in the input scan, and then it will perform the program scan, so that the program scan will refresh, or it will take the decision based upon the input status. Then accordingly, the output scan will also be performed, so that the outputs will get updated. It won't get freeze, but it will get updated instantly with respect to the change in the input, and with respect to the logic, the output will get updated immediately. So this process is a continuous. So this like a cycle. So input scan, program scan, and then output scan. So like this, it's a cyclic process, right? Then what is the significance of this programming device? This programming device is to, whenever you write a program, right, or whenever you want to change, or when you want to update the logic inside the PLC, we use this programming device, and we will interface this device to the PLC. We will connect to them, and then we will update and we will modify the logic. Or if you want to replace the completely with a fresh logic, then again this programming device will help you a lot. Sometimes the programming device may be an HMI, or maybe some other devices which is where we can able to monitor the status of the operation. Okay, we will discuss about all these things in detail in the later sessions. Next, coming to the input module and the output module, these comes with the different types, like it can be a digital or it can be an analog. So what is the basic difference between the digital and analog modules? See, if the operation is like turning the whether it is an input and output, if it is an just like an on and off, or a binary 0 or 1, then it comes under a digital. Say for example, if you take a proximity sensor, so if any object is sensed by the proximity, then it will sense as high. If there is no object, then it is a 0. Similarly, if you take a switch, if you turn on high, otherwise 0. Similarly, the output section, if a lamp is turned on, it's a high state or else off state. So motor on and off, all these things will come under digital 0 and 1. Whereas the analog, in the analog, it is completely different from the digital on and off. In analog, it has a range. It has a range. So the input can be varied. Say for example, instead of a on-off switch, let's have a pot. I have a pot potentiometer, so I can vary the range. I can vary from minimum to maximum. Same is the case with the output. Let's say previously in the digital, I can make the lamp to turn on or off, right? But in analog, I can able to change the intensity of this lamp. I can change the intensity from minimum to maximum, so I can fix the intensity level on a percentage or on a 0 to 100 scale, right? So this comes under analog, whereas in digital, it's only turning on and off, right? So the input and output modules can be digital and analog, right? So moving on, what the devices or what are the logics before the PLC, right? PLCs are, I said, it's a microprocessor base. So PLC purely depends on the computation based on the processors. So processors, it has invented in the 1970s and 1980s. So what before, before the PLC, before the programming devices, the relay logics were used. Now, what is a relay logic, or what is a relay actually? Relay is an electromagnetic switch. Right, so it consists of an electrical, some wiring and some electrical, an electromagnetic coil and some moving parts in it. So here, basically, when you look at the relay logic panel board, it's very complex, and troubleshooting of this panel boards are very difficult, and also the modification is also very difficult because it is all hardwired and it's fixed. So customization is not possible. If you want to change the logic, it's not possible. So whatever the design is done, it's fixed, right? And the maintenance is also very difficult. It consumes a lot of power, and it has a lot of moving parts, and it's very noisy. This was the case with the relay logics. But so when you look at the relay, the operation, so here basically it consists of 5 terminals. So one is a common terminal, and coil terminals, and normally open and normally closed. So how we can understand this? See, if you want to connect a bulb to a battery, then here this is how the design will look like. So here is a battery, and here is a switch, and here is my lamp, right? So if I close this lamp, then the bulb gets energized. Clear? So now let us think that the one of the terminal, so this is connected to common. So let us say I've connected this common terminal to the positive. Now where this common terminal is going, it is going through this hinge and through this armature. Now by default, it is connected to this particular point. Let us say this is a point A, right? So this is connected to a point A. So by default, now it is in contact with point A, which means my supply, whatever I connected across this common, is available across this normally closed terminal. So here I can get this supply, right? Now the game changes when I give a supply to these coil terminals. See, basically this relay is an electromagnetic switch. So what do you mean by electromagnetic switch? Unlike your normal conventional switch, when you press a button, when you apply some mechanical force, the contact occurs. But in the relay, if you give a small tiny voltage to this relay, then the contact occurs. So that's what I'm talking about. These coils, right? The relays comes up with the different ratings, 5 volts, 12 volts, 24 volts, 48 volts, and more. So different ratings are available. Let's say I'm using this 24 volts relay. So if I give this 24 volts across this coil terminals, then what happens? The current, the electricity will pass through this coil, and then this coil becomes an electromagnet. And what happens when it becomes an electromagnet? It pulls this arm, it pulls this armature. So when it gets pulled by this coil, then what happens? Instead of contact with A, it makes a contact with B. So it makes contact over here. So this happens when I provide this supply. That's what the title justification, electromagnetic switch. So by providing this this signal, it becomes a magnet, and then it subsequently it makes a contact, it makes a switching. So previously I used to get the supply across this NC, and now I can able to get the supply across this NO. Right, so this is what happens with the relay. So that's why I said in relay logic there are some moving parts, it consumes power, and it's a hardwired, no customization is possible. So early the logics were built based on this relays only. I hope now you understood how the relay works, right? So this is a commercially available relay boards. So this is how it look like. So you can see this, it supports the 10 amps. You can connect a load of 250 volts, and this relay works for 30 volts. And also you can connect a load of 125 volts for a load, and this relay coil requires just a 28 volts. So it means these coils here, this is the coils. So these coils can draw 28 to 30 volts. So this is a supply required for a switching. And across this common, you can connect a 240 volts AC supply. You can connect a 240 volts AC supply because it has a rated up to 250. And whatever the supply you connect across this common terminal, by default, when there is no supply to the coils, you will get that supply across here because it is a NC, right? This is a NC. But when you give a supply to these coils, then what happens? You will get that over here. So the switching happens. So switching happens based on this coil supply. So this is how the relay works. Okay. Now, this is how the panel boards look like. So very complex, very big, right? All moving parts, all the relays, right? And if any fault occurs, you need to replace, you need to remove this faulty relays, and then you need to replace with a new one, right? And now, as we are in the digital era, that entire relay boards are replaced with this modular PLC. Why I'm saying this is a modular? Because here these are the modules, right? These are the input output modules. I can customize this PLC. I can customize the PLC according to my application, according to my requirements. So how many inputs and how many outputs are required. So based on that, I can customize the PLC. So here in the modular PLC, you will be having a very powerful CPU and the power module, and followed by the input output modules. So this is a commercially model of Allen Bradley, and from Allen Bradley, a modular PLC. Similarly, you can see a Siemens model. So this is also a modular type, and you can see we can do the programming by using this engineering system. So an operator can fix this programming device to the PLC, and he can modify, he can do the customization to the PLC. Now, what is the advantages of PLC, programmable logic controller? It's very fast, easy to change the logic, it's very flexible, reliable due to the absence of moving parts. There is no, in relay there are moving parts, but in the PLC there is no moving parts, right? Only it's a microprocessor, and it performs or it executes the instructions. Low power consumption, easy to maintain, and it's modular. You can customize as per your requirement. Facilities and fault finding, diagnostics, everything becomes very easy. good in documentation facilities, capable of handling of very complicated logic operations. Yes, you can perform even a very complex operations in the PLC. Easy to couple with process computers like HMI and SCADA. Analog signal handling and closed loop control programming can be done easily. Counter, timer, and comparator can be done. Programming can be done using this PLC. So it comes under the sequential programming. So that is our major advantages with the PLC. So that's it for this topic. So we will continue in our next lecture. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.